So in this video, we're going to go through sample question 13 from the Society of Actuaries ExamP list of sample questions. All right, another fairly simple one focusing on general probability. An actuary is studying the prevalence of 3 health risk factors, denoted by A, B, and C, within a population of women. For each of the 3 factors, the probability is 0.1 that a woman in the population has only this risk factor and no others. Okay. For any 2 of the 3 risk factors, the probability is 0.12 that she has exactly those 2 risk factors, but not the other. The probability that a woman has all 3 risk factors, given that she has A and B, is 1/3. We want to calculate the probability that a woman has none of the 3 risk factors, given that she does not have risk factor A. Right, a lot of information here. Let's see what we can gather. So the probability, so we have 3 risk factors, right? And the first thing it says is for each of the risk factors, the probability is 0.1 that she has that one and only that one. So for example, the probability that she has risk factor A and not risk factor B and not risk factor C, right? B complement, C complement, that's equal to 0.1. And that's going to be true for A complement and B and C complement, as well as A complement and B complement and C complement. The reason I'm not writing them out is just because I think this is such an obvious example of where a Venn diagram will definitely help you out, because it's talking about you can have these risk factors, and when you there's a situation where you only have one and there's an overlap and you could have 2. So let me just show you kind of how to set up the Venn diagram. So obviously you could have none of the risk factors, right? So that's going to be, everything's going to be contained within this box. And you could have risk factor A, you could have risk factor B, and you could potentially have risk factor C. Now, these sections would be the probability that you have that risk factor and only that risk factor, and we're told that that's 0.1. So that's easy enough to fill in. Then we're told that for any 2 of the 3 risk factors, the probability is 0.12 that she has exactly those 2 risk factors, meaning she would not have the third. So 0.12 here, 0.12 here, 0.12 here. And then the last thing it gives us is the probability that a woman has all 3 risk factors, given that she does not have A and given that she has A and B is 1/3. Now that's not something we can fill in into like a diagram like this, like conditional probabilities don't work. Intersections and unions work. These are good for intersections and unions. So let's take a look. So the conditional probability that a woman has all 3 risk factors, so probability that she has A and B and C, given that she has A and B. All right, they give us this as being 1/3. Now, what is this? We should be familiar with the formula for conditional probability. This is the probability that she has all 3 of these, right? A intersection B intersection C and A intersection B is just simply the probability of A intersection B intersection C. It's almost as those things here are redundant, right? Like, what's the probability that she has risk factor A and B and C and A and B, right? So that's going to be our numerator divided by this thing here, the probability that she has A and B. And that's equal to 1/3. Okay, what are we looking for? All right, ultimately, we're looking for this, the probability that a woman has none of the 3 risk factors. So the probability that she has A complement and B complement and C complement, given that she does not have risk factor A. So given A complement. So that's what we're essentially looking for. And we need more information in order to do that. Okay, so primarily, right, we're going to need to know the probability of risk factor A in order to figure out the complement, right? Because this, using the conditional probability formula, is the following. We're looking for the probability of A complement, B complement, intersection C complement, over the probability of A complement. Okay, and in order to do any of this, we really need to know these two missing things, right? We need to know the intersection of all three risk factors, as well as the probability that she has none of the risk factors. So let's go about figuring that out using this. So in order to find this out, I'm going to just label this X. And from there, I'll just start filling in this equation. So the probability that she has all three, well, that would simply be X, right? Now, the probability that she has A and B would be X plus 0.12, right? And that's going to be equal to 1 over 3. And hopefully this should seem pretty easy. This is just high school level algebra at this point. Multiply to both sides, it's 3x is equal to x plus 0.12. I subtract the x to both sides, 2x equals 0.12. I divide by 2, x is equal to 0.06. Right, so this is equal to 0.06, that she has all three risk factors. Okay, so based off this, what is the probability that she doesn't have any of the risk factors? Well, that would be simply everything in here. So 1 minus everything in here, right? So I just do 1 minus 0.1 minus 0.1 minus 0.1. Then minus 0.12 minus 0.12 minus 0.12. Then minus 0.06. And it gets me 0.28. Right? You should be familiar with all like every mutually distinct item in a sample space should add up to 1. Right? So all of this, that should add up to 1. That's how I got this to be 0.28. So since this is 0.28, we can actually go about figuring this. So what is the probability that she has none of the risk factors? Well, 0.28 that we got there, divided by the probability that she doesn't have A. The probability that she doesn't have risk factor A should be 1 minus the probability that she does have A. And the probability that she does have A is just the sum of all these parts of the Venn diagram, right? So 0.1 plus 0.12 plus 0.12 plus 0.06. And that gets us 0.4. So 1 minus 0.4 is 0.6. Solving for that, we have 0.28 divided by 0.6. And we get 0.4666 repeating, of course, so actually like that. And that, of course, would round to, since this is to 3 decimal places, 0.467. Answer choice C. Okay, so overall, not a difficult problem. It required just a couple of things coming into it. You needed to know how to really work a Venn diagram. You needed to know the formula for conditional probability, as well as dealing with intersections and complements. You should know that the sum of all of every mutually exclusive element in a sample space should add up to 1. But other than that, it was just working through the problem and just trying to understand what it means. Hopefully, going through this example made this problem more clear. If there are any questions, leave it down in the comments. If you want to see some more worked out questions like this, for ExamP, I have a playlist. And if this video helped you, give it a like, because that definitely helps me. Other than that, good luck, guys.